Okay, let's do a couple of exercises from Anton. So this first one here says find the vector x such that this equation here holds true, where we're given that u is equal to this vector in R4, v is this vector, and w is this vector. So these are just tuples of four numbers, of four tuples, and they're vectors in R4. Okay, and the point is that vectors behave a lot like follow the familiar rules from algebra. So I want to find x. So let's get all the x's to one side. Well, there's only x appearing here. So let's leave the x over here and move this 2w to the other side by subtracting 2w from both sides. So that's what I did here. And then this 2w and this 2w combine to a negative 4w. And so I have 3x is equal to this thing. And then now I just substitute in what u, v, and w are. So 3 times u, remember scalar multiplication, multiplies each component by the particular scalar. So 3 times this 3 times that 3 gives rise to a negative 9. This 3 times that 2 gives rise to a 6, and so forth. So I won't go through the arithmetic. But then once you simplify this, you get these three vectors, and then addition is component-wise. So the first component, negative 9, you add that to the first component here, which is 4, and then the negative 20 here, I distribute this negative sign across. Okay, so that's what the first component becomes, negative 9 plus 4 minus 20, and that simplifies to negative 25. And then I similarly found the other components, and then so that's what equals 3x. And then to find x, I multiply both sides of the equation by 1/3, and 1/3 doing scalar multiplication of each of these, I divide each of them by 3, and I get this answer. Okay, let's move on to another problem. So this one here says, show that there does not exist scalars c1, c2, and c3 such that c1 times this vector plus c2 times that vector plus c3 times this vector equals this. Now, this type of question will come up a little bit later in a ensuing chapter, and what it's saying is that this vector here is not in the span of these three vectors. So yeah, that's kind of why this is a natural question to ask. But right now, let's just work on figuring out the solution. And basically, let's just pretend that there was a solution. Let's try to find it. Okay, so let's expand out in terms of vectors what this vector is. Well, c1, this is scalar multiplication. So that means we multiply each component by c1. So that's what I've done here. Similarly, c2, multiply each component by c2. And then c3 likewise. So now we want to add these three vectors, and vector addition is done component-wise. So I take the first component here, the first component here, and the first component here, and that's going to be my new first component. Likewise for the second components, and then the third components. So I collected them here. And so if these two vectors are equal, if and only if their components are individually all equal to each other, so in other words, the first component here equals the first component here. The second component here is equal to the second component of 5 here. So that's why this sum here is equal to 5, or should equal to 5. And similarly with the last component here. So we want to solve this system of equations for c1, c2, and c3, or eventually essentially show that no solutions exist. And then we've seen how to do this in chapter 1. It's make this augmented matrix and then row reduce. So I've done the details here, but let me not go through that. Instead, let me show you how to do this in Sage Math. So we go to cocalc.com, and then we let's go to you could either click on Sage Math 9, or I guess what I'm used to is clicking on New and just click a new Sage worksheet. Okay, great. And so now let's enter our augmented matrix. And it's disappeared up above, but I've copied it down, and once you enter the matrix, so it's a 3x4 matrix. I've entered all the entries just in one fell swoop, and then ask, what is this matrix A? Well, it's this matrix here. And then, okay, doing the row, finding the reduced row echelon form of it, we get this. And this line down here tells us that there's going to be no solution here, that this very last row, because 0 can't equal 1. And so this system of equations has no solution. If this one had been a 0, then there would be infinitely many solutions, actually. And the C3 would be a free variable, but because it's not 0, there's no solution. 0 can't equal 1. Now, when I did the problem in class and did all the arithmetic by myself, I got it down to this form here. It's very close to this reduced row echelon form the computer found, but I stopped at this step, didn't bother continuing and changing this to a pivot 1. But yeah, we see essentially again that we've got 0 equaling some non-zero thing, and that just can't give rise to a solution.